Hello everyone, I'm Laura Wynn and we're going to be learning about length, volume, and area. Let's go to my PowerPoint and we can get started on our homework problems. All right, so Module 3, Chapter 10, Length, Area, and Volume. Okay. There we go. Our first problem, it gives us some, let's see, equative, whatever. So we got 1 jigger is equal to 2 mouthfuls, 1 pint's 2 cups, 1 jack is 2 jiggers, 1 jill is 2 jacks, and the list goes on. I'm not going to read through them all. You guys can if you want to. Now, it wants us to find how many mouthfuls are in a jill, how many mouthfuls are in a cup, and how many mouthfuls are in a pint. Now, we look at over here at what it gave us, and we know 2 mouthfuls is equal to 1 jigger. So we need to figure out how many jills or how many mouthfuls are in a jill. So we look at jiggers. We know there's 2 jiggers and 1 jack. So that would give us 4 mouthfuls in 1 jack. Okay, so we got 2 jacks in 1 jill. So if there's 4 mouthfuls in 1 jack, that means there's going to be 8 mouthfuls in 1 jill. Okay, our next one, it wants us to figure out how many mouthfuls are in a cup. So we know that there's 2 jills in 1 cup, and 1 jill is equal to 8 mouthfuls. So we just multiply that by 2. 8 mouthfuls times 2 gives us 16 mouthfuls is equal to a cup. The last one it wants us to do is how many mouthfuls are in a pint. And we look over here, let's see, there's 2 cups and 1 pint. So we just multiply 16 by 2, which gives us 32 mouthfuls is equal to 1 pint. Now there's another step to this problem, and it wants us to fill up an empty pail. Here's our empty pail. It wants us to put in, let's see, a mouthful, 1 jigger, 1 jack, and so on, all the way to 1 gallon. And they want us to know, is the pail going to be full, overflowing, or is there room for more? So I had went ahead and filled us up our little pail. Now it's almost completely full, but not quite there. By the calculations, there's room for at least 1 more mouthful in this pail. All right, problem number 2. This one wants us to find the perimeter and the area of a triangle. So the first things you need to know are the area of a triangle formula, which is A is equal to 1/2 base times height. And perimeter is the length of the side of the triangle. Okay, here's our first triangle it gives us. Now we need to find the area of the triangle. So we know that area is equal to 1/2 times base times height, which B stands for base, which is going to be 82.3 in this problem, and the height is actually 41. We multiply those together and it gives you 1,687.15 meters squared. Now to find the perimeter, you just add the outside sides of the triangle. So we have 48, 69, and 82.3. You add all them together and it gives you 199.3 meters. All right, our second one. Again, you need to know the formula of an area of triangle and what a perimeter is, which is the length of the sides of the triangle. Here's our triangle it gives us. Now it's going to say area is equal to 1/2 base times height. Our base is up here is 88.8 and our height is 37 inches. Multiply them together and it gives you 1,642.8 inches squared. Now do not forget the squared part, because when you multiply an inch by an inch, it's going to square it. Now the perimeter is just the outside. So all the lengths of the outside of the triangle, you add those together and it's going to give you 222 inches. Now since you're not multiplying, it's not going to be squared. It's just plain old inches. Our third problem for this area and the perimeter, here's our triangle it gives us. Now this is a little bit different than the last ones. The other ones are pretty simple and laid out there for us. So we know area is equal to 1/2 base times height. That's the area of the triangle. So our base is 6.2. Now you look at all these other numbers and you may think 3.1 might be the height, but it's not. It's just the length of this side right here. So our height is actually 2.6. So you multiply 6.2 and 2.6 together by half, and it gives you 8.06 centimeters squared. Now the perimeter, that's where the 3.1 comes in, because that is actually the length of one of the sides. So you add up all the sides, and it gives you 17.8 centimeters. Okay, this next one, it gives us this beautiful shape. Now it is it's a square with the sides of 10. Each side of the square is 10. It is inscribed in a circle and circumscribed around another circle. It wants us to find out which is larger, the area of the region between the two circles. So this little green area, is that the larger area? Or the area inside the smaller circle, okay? So in order to figure this out, you need to do some math. We need to know what the area of a circle is, which is pi radius squared. Now, since it gave us the 10 units for each side of this square, we know that the radius for this smaller circle is going to be half of that, which is 5. So we can plug that into our formula. So for the smaller circle, our area is equal to 25 pi units squared. Now we need to find the radius for our larger circle. In order to do that, we use the Pythagorean theorem, which you just plug in the 5 for the a and the b to get the radius squared, which would give us 50. All right, here's our larger circle. We plug that into our area of a circle formula, which r squared, we figured it out up here, so it's 50 pi units squared. Now, in order to figure out the regions, or the area of the green, we need to subtract the small circle from the large circle to find out the area. So you plug that in. It's 50 pi minus 25 pi, which gives us 25 pi units squared. So to answer the question to this problem, the area of the region between the circles is the same as the area of the smaller circle. As you can tell, 25 units and 25 units. So it's 25 pi units squared. Okay, let's work on our next one. This one gives us this shape here. And it wants us to, all right, it tells us that that the right circular cylinder and the cone in this picture both have a base of radius r and a height of 2r, and the sphere is a radius of r, which I have that in a picture. Here we go. Okay, so there. This is just all these shapes that are in here in this picture they gave us, pulled out and gave with the information. So we know the cylinder, its height is 2r, the cone's height is 2r, and they all have a radius of r. We need to find the volume of the circular cone, the cylinder, and the sphere. Now to find the volume of the circular cone, we need to know, the volume of the cone first. That formula is V is equal to 1/3 base times height. And since the bottom of the cone is a circle, we know that the area of a circle is pi radius squared. Now we add those together to get us, or multiply them together, add them together, my bad, I'm sorry guys, and to give us this formula, the volume of a circular cone, which is V is equal to 2/3 pi r cubed. Now we need to find the volume of the cylinder, which is this one right here, with the information that they've given us. So the volume of the cylinder, without any information, is V is equal to base times height. And again, the area of a circle is pi radius squared. With the information they have given us, we need to plug that in, which gives us 2 pi radius cubed. Now, for the sphere, the formula for that is 4/3 pi r cubed. Now, it needs us to show that there's, it wants us to divide the volume of the cone by the volume of the cone divide the volume of the sphere by the volume of the cone, and the volume of the cylinder by the volume of the cone, to show that there is a ratio of the volumes of the cone to the sphere to the cylinder, which is 1, 2, 3. So when we do the math, that's going to give us a 1. The volume of the sphere divided by the volume of the cone will give us 2. And the volume of the cylinder divided by the volume of the cone gives us 3. All right, so our next problem. This is a right trapezoidal prism. So here's the numbers it gives us, and it wants us to find the surface area of this figure. Okay, in order to do that, we need a formula to plug in. So the surface area is equal to 2 base plus perimeter and height. All right, so I have it color-coded. Hopefully it helps some. So to plug it in, the base is 26, 12, and 17. So all the green numbers are the base. The perimeter is the green numbers plus this white number, 15. So 26, 17, 12, and 15 added together gives us 70 times the height, which is 4 centimeters. So remember, perimeter is the length of all the sides. 4 is not a length, it's the height. So when you plug that in to our formula and you work it, it gives us 784 centimeters squared. The next one it wants us to work is a right triangular prism. Again, kind of color-coded it a little bit. Here's our formula that we're going to use, just like the last one. 2 base plus perimeter and height. So we know that the blue is our base. So 8 and 15, we plug that in for the B. 40 is the perimeter, which is the white, 17, plus 8 plus 15 gives us 40. And the height of this right triangular prism is 7. So plug all our numbers in for our variables and you solve it, which is going to give us the surface area of this right triangular prism is 400 meters squared. All right, problem number 6. We are almost through, guys. Are you ready? Now it gives us this shape here. And you're looking at this object and you're like, how are we going to do this problem? Well, for this one, it wants us to find the surface area and the volume of this object. The easiest way I can show you how to do this is we need to break up this object. What shapes do we see inside of this object? Well, right here in the middle, we see a cylinder, and on the ends are hemispheres. And when you put 2 hemispheres together, what do you guys get? You get a sphere. There we go. All right, and we get our cylinder. Now we need to know our formulas. So we need to know the formula for the surface area of a sphere, which is 4 pi r radius squared. Then the area of a cylinder is 2 pi r h, which h is the height. Okay, so the surface area for the object up here that they have given us, we just add the surface area of the sphere to the surface area of the cylinder, which gives us this formula. And all we have to do is just plug our numbers in for our letter variables. We need to figure out what our r is, our radius. So we know the diameter is 8. So radius is half of the diameter, so that will give us a 4 for our radius. And our height is actually 21. So we just plug in our numbers and we add it up. Work out your problem. Gives us 729 feet squared. Now we need to figure out our volume. So the volume of our object is 4/3 pi r cubed plus pi r squared h. So you plug in our numbers for our letter variables and you work it out, and that gives you an approximate volume of 1,324 feet cubed. All right, we are down to our last problem, guys. We are almost done with our homework. I hope this has helped you all figure this out. Here's the object it's given us. Now, if you look at our object, what 2 shapes do you see our object's made out of? Well, the top part of it kind of looks like a cone, which it is, and the bottom is a cylinder. So here's our shapes that our object's made out of. There's our cone, and here's our cylinder. Now, for our cone, we need to know the area of the cone. And if you notice, the bottom of our cone is a circle. We need to do what the area of a circle is. So here's the circle for the base, which is pi radius squared. The area of the cone is pi radius s, which is the slant length of it over here, of our cone. And then we need to know the area of our cylinder, which is 2 pi radius h. Okay, so our object over here, the surface area for it, we just add up all 3 of these together. So there's our formula for the object that they have given us. Now, we need to plug all this in. So, like I said, our radius is 2, our S, our slant length is 6, and our height is 10. So let's plug our numbers into our variables, which is going to give us approximately 176 meters squared. Now for our volume, it's going to be a little bit different than our last one. So let's go ahead and get to it. Right here, for our volume, we're going to have an H1 and an H2. Now to figure out what our H2 is, we use the Pythagorean theorem, which if you look up here, here's our little triangle. So we know what, here's 1, there's 6. We'll put 6 down here in our Pythagorean theorem. 6 squared minus 2 squared will end up giving us approximately 5.66. So that's what our H2 is going to equal to for us to plug it into our formula. So here's the formula for our volume. Pi radius squared H1, there's our H1, plus 1/3 base times H2. Now the H1 is actually the height of the cylinder. So this is going to be the height of the cylinder. Radius again is 2. Okay, so height of the cylinder is H1. The base area of the cone, we're going to plug in there. And then H2 is what we just figured out, which is 5.66. So let's plug in all our numbers into our variables. Okay, and then it's going to give us approximately 149 meters cubed. So I hope this has helped you guys with your homework for length, area, and volume. And this is all I have for you guys. So I hope you guys have a good day. And thank you for watching.